All right, let's just dive right in. Today we're tackling a universal headache for pretty much every app developer out there: loading states. I'm going to show you a two-tier loading architecture for your React Native apps that'll turn that frustrating mess into something clean, scalable, and, well, professional.
So be honest. Does this look familiar? You tap a button, and you're just kind of left hanging, wondering, is it working? Is it broken? What's going on? It's a super common problem. And this is what happens, right? It's just an inconsistent mess. You get a random spinner on one screen, a jarring blank page pops up on another, and maybe a button just grays out with no other feedback. For the user, it feels broken. And for you, the developer, it's a total nightmare to manage.
Yeah, this is what we're calling the loading state mess. It's that thing that happens when loading indicators are just thrown in ad hoc, screen by screen, with no real strategy behind them. And look, this isn't just about making things look pretty. An inconsistent UI, that leads directly to a poor user experience. It makes your app feel kind of janky and it erodes trust. And behind the scenes, it creates tangled, brittle code that's a pain to maintain. So fixing this really does help everyone.
So what's the fix? How do we get out of this mess?
Well, we shift from that chaos to clarity with a really elegant two-tiered solution. It's time to stop treating all loading as the same problem and give it the nuance it actually needs.
And this slide right here, this is the core idea, a clear separation of concerns. Think of it like this. On one hand, you have a global loading overlay. This is for the big, critical, app-wide stuff. On the other hand, you have local loading screens for specific, in-the-moment tasks. This gives us both consistency and flexibility. Let's break down each tier. Okay, first up, Tier 1, the global overlay. Think of this as your app's universal, please wait, something important is happening signal. It's simple, it's consistent, and it is powerful. Its job is to cover the entire UI, blocking any accidental taps while a critical action, like saving data or submitting a big form, is happening in the background. It's the ultimate safeguard.
And what's really key here is how you implement it. You don't need to sprinkle this component on every single screen. Nope. You just define it once at the very root of your application, and it's ready to be called from anywhere in your app, whenever you need it. It's set it and forget it.
Okay, so that's our big global hammer. Now let's talk about the scalpel. This is Tier 2, the screen-specific states. This is where we handle the unique loading needs of individual screens. Because, let's face it, a list view has totally different needs than a simple data display. Our first use case is a classic. A screen that shows a list of items, like posts, that you can refresh. Now, using that big global overlay here would feel heavy-handed, just totally out of place. The logic here is super smart. You show a dedicated loading indicator only on that initial load, when the screen is totally empty. After that, it's just the standard pull to refresh that users already expect. It just feels right. Next up, let's think about a screen whose whole job is to fetch and display some data from an API for the very first time. There's literally nothing to show until that data arrives. For this scenario, a local loading screen makes perfect sense. It clearly communicates, hey, I'm getting your content, and then it gracefully replaces itself with the API response once it's ready. Clean, simple, and really effective.
Now, forms. This is where things get really interesting. When a user hits submit, you need to do two things: give them immediate feedback and prevent them from messing anything up. This is a perfect hybrid use case.
And this is a brilliant combination of both tiers working together. Locally, you give that instant feedback by disabling the button and changing its text to submitting. But at the exact same time, the global overlay kicks in to block all other interactions. It's really the best of both worlds: local feedback and global protection.
Our last example is another really common one: saving changes on a profile or a settings screen. This is a critical task where you absolutely want to prevent the user from navigating away or changing other things while that save is in progress.
So here we go straight to Tier 1. The user taps Save, and the global loading state is immediately triggered. The overlay fades in, the UI is blocked, and the data is safely. It's a crystal clear signal to the user that their action is being processed.
And of course, it's just as important to know when not to add loading states. For simple, static screens like a home screen or a details view that gets its data from a previous screen, no loading is needed at all. The whole point is that the architecture is only applied where it actually adds value.
Okay, let's bring it all together and look at the complete blueprint. This is the payoff: a clear, predictable system for handling any loading scenario you can throw at your app.
This table is a great little summary. For those critical can't-be-interrupted tasks, like a form submission or saving a profile, you use the global overlay. For initial data loads, like a posts list or an API fetch, you use a local state. It's all about choosing the right tool for the job.
And the end result is exactly what we wanted from the start. A professional, consistent user experience powered by code that's flexible, simple, and easy to manage. No more chaos.
But we're not quite done perfecting this. In our next explainer, we're going to take this solid foundation and add a layer of polish by bringing smooth animations to that global overlay, making those transitions feel even more seamless.
So, with this pattern in your toolkit, you've solved one of the trickiest, most annoying parts of UI development. And that leaves you with one simple, exciting question. Now that your loading states are clean, what will you build next?